So I'm going to do a lesson 15 recap, which was how to multiply decimals. So our example today is 9 3/10 times 4 1/10. We learned that we can use the standard algorithm to multiply decimals. We need to, one, count the number of decimal place values in each number. So my 9 3/10 we can also represent as 9 3/10 in fraction form, meaning we have one place value after the decimal. And my 4 1/10 we can represent as 4 1/10 in fraction form, being as though we have one decimal after the decimal point. So then we see that we need to move two decimal place values in total at the end of our product. Now that we are going to multiply, we're just going to leave the decimals alone and worry about them at the very end of our multiplication. So 3 times 1, 3. 9 times 1 is 9. We're just going to do our basic standard algorithm like we will always do. So just really quickly. And then once we get our answer to our standard algorithm, we know that 3,813 is not reasonable given that we multiply 9 3/10 times 4 1/10. So this number right here, 2 places that we got in the beginning, tells us that we need to move our decimal 2 place values, giving us the answer of 38 1300ths. So we learned that in lesson 15. Our key takeaway is that we can count the number of decimal place values in a factor to get the number of decimal place values that we will need in our product. This is a skill that you're going to need for lesson 17, the one that I'm going to show you guys today. So in lesson 17, different from our normal package, this lesson starts directly with the interactive new material because we're going to work directly with the real world problem. So it says Ben wants to make 100 name tags with ribbons attached to them. Each name tag requires 5 centimeters of ribbon. She has 3 2,500 meters of ribbon and 6,500 meters of silver ribbon. Exactly how many more centimeters of ribbon does Ben still need to make 100 name tags? So as always, I am annotating using the cube method to solve my problem. First things first, 5th grade, we know that we need a goal. So in this problem, our goal is to find the centimeters of ribbon. So the word centimeter or cm is going to be very important. To find the centimeters of ribbon still needed to make 100 name tags. So that is our goal for this problem. Next, we're going to talk about the things that we know. So the context of this problem, we know that we need a total of 100 name tags. Each name tag takes up 5 centimeters. We're just going to keep underlining our units of measure. So each name tag is 5 centimeters. We currently have 3 2,500 meters of ribbon, of one color ribbon. So I'm going to put the M to represent meters. That's going to be important. We also have 6,500 meters of silver ribbon. Those things are going to be very important. If you notice, each name tag requires 5 centimeters. However, we have our current amount of ribbon in meters. So we will have to convert. I'm just going to model that really quickly so that we can see what it is that we have. So we have 3 2,500 meters of ribbon and 6,500 meters of ribbon. What we need are name tags that take up 5 centimeters. We're not sure how many name tags we're going to need or how many centimeters we're going to need, but we know that each of our name tags is going to take up 5 centimeters. So our first step in this problem, we're going to find the total number of ribbon we currently have. Doing that, we're simply going to add our 3 2,500 meters to our 6,500 meters. And we got 3 and 90 meters of ribbon that we currently have. This is how much we have already. All right, great, here we go, step 2. Step 2, we're going to find the total needed. We're going to find the total amount of ribbon needed. So we already know, based off the concepts of our problem, that we need a total of 100 name tags. So 100 name tags needed. Each name tag is 5 centimeters. So 5 centimeters per tag. So we will need a total of 100 times 5. So we would need a total of 500 centimeters for all name tag. All right, so if you notice that the number that we need is currently in centimeters, and the number that we have is currently in meters. Unfortunately, we are not able to just use those two numbers. We need to first things first convert. So we are going to convert our 3 and 90 meters into our centimeters. So here we go. For step 3, we are going to convert to the same unit. And this is a skill that you guys have been working on in tutorial. So we know that 1 meter equals 100 centimeters. Again, that's 1 meter equals 100 centimeters. If we start with 3 and 90 meters, we need to figure out how many centimeters that is. So we will have to multiply. So we are going to do 3 and 90 meters times 100 centimeters. And we are going, that means, well, that tells me that I need to move my decimal 2 times to the right, giving me 390 centimeters. So I know that I currently have 390 centimeters. That's going to be very important to solve our problem. Before we even go to actually solving our problem, we are going to estimate. So you guys also practice estimating in lessons 16 and 17, estimating decimals. So before we solve, so step 4, we are going to estimate and solve. So before we solve, we are first going to estimate. Our problem now shows 500. Our actual problem shows 500 minus 390. That will be our actual. But before that, we are going to estimate. So I'm going to keep my 500 the same. My 390 will estimate to 400. So it's very closer to 400 than it is to 300 or to 350. We know that 500 centimeters minus 400 centimeters is 100 centimeters. So our estimate is that we'll need about 100 centimeters to make the additional ribbons. Let's figure out if that estimation is reasonable based off our actual answer. So 0 minus 0, our 0 becomes a 10, 5 becomes a 4, 10 minus 9 is 1, 4 minus 3, is 1. So our actual answer proves to us that we will still need 110 centimeters of ribbon to make 100 name tags. So as always, we are going to figure out if our answer is reasonable. We know that our answer of 110 centimeters is very reasonable. It is in the same ballpark as 100 centimeters. Of course, last thing, we need to write our final sentence. So our final sentence will read, he will need 110 centimeters of ribbon to make 100 name tags. So our key takeaway for this problem and for this packet is going to be that measurements must be the same units before operations are performed. So remember, all of our measurements must be the same before we perform any operations.